Okay, so now that you've had the opportunity to watch some videos explaining how to do these problems, here are a few examples that you can practice yourself. So we're going to simplify these rational expressions, and we're going to use the information here provided that the values that are excluded from the domain because they make the denominator undefined. We're going to use that in assisting us to simplify these. So if you haven't had a chance yet to solve each of these, I would pause the video, go through and try solving all three of these or simplifying all three of these, and then come back and rewatch the video to check your work. So here we go. In the numerator here, the first thing I'm actually going to do is I'm going to factor out a -1 so that the first term is positive. So -1 times w squared plus 3w minus 54. And in the denominator, the first thing that I'm going to do is I'm going to factor out a GCF. So again, I want that first term to be positive, so I'm going to factor out a negative. They're all divisible by 10, so I'll factor out a 10, and they all contain at least one w, so I can factor out a -10w. If I factor out a -10w, I'm left with w squared plus 6w minus 27. Now we said that this information up here helps us in terms of factoring the denominator. It's not going to help us in factoring the numerator. So we're still going to have to factor that sort of the traditional way. So we need to figure out the factors of -54 that also happen to have a sum of 3. So that would be positive 9 times -6. That has a product of -54, but a sum, if we add those, a sum of positive 3. So we're going to factor the numerator as w plus 9, w minus 6. And again, to check that, just FOIL it back out and you'll verify that that is correct. Now down here in the denominator, we're going to not have to do that. All right, it's already sort of there's enough information provided that we don't really need to go through this process in order to factor it. So the -10w, that is right here. So this is the reason why w cannot equal 0, because in this GCF of -10w, if we were to evaluate for w equals 0, this factor equals 0, so the product in the denominator would be equal to 0. So I know that that's why we're saying w cannot equal 0. This tells us the two binomial factors. So I could list the factors of -27 that also have a sum of positive 6, or I can just look here. So because w cannot equal -9, I know that one of the binomial factors must be w plus 9. Because if I were to evaluate -9 plus 9, this is 0. Well, if this factor is 0, then the entire product in our denominator equals 0, and the expression is undefined. The other factor I can tell from this right here is going to be w minus 3. All right, because if I evaluate for 3, this factor equals 0, so the product in our denominator equals 0, and the expression would be undefined. It's a good idea to always, just real quickly mentally FOIL this to make sure it does match. So w times w is w squared, w times -3 is -3w, 9 times w is 9w, well 9w minus 3w is 6w, and 9 times -3 is -27. So it's a good idea just to do that so you're 100% sure. Now that we've written this expression, the numerator and the denominator have been factored, we can reduce and cross out any common factors. So looking here first, -1 over -10, well, a negative divided by a negative is just positive, so that reduces to positive 1/10 w. W plus 9 over w plus 9 is going to reduce. Those are just going to simplify to 1 over 1. And that's it. That's all that simplifies. So in the numerator, we have 1 times w minus 6. So we have w minus 6 over, in our denominator, we have 10w times w minus 3. So 10w times w minus 3. And that's it. That's our simplified expression. So we'll do the same thing over here. Looking first at our numerator, I'm going to factor out any GCF. So there's a GCF here of 9. If I factor out a 9, I'm left with x squared plus 3x minus 18. In our denominator, we have a GCF of 4, so they're all divisible by 4. So if I factor out a 4, I have 4 times x squared minus 6x plus 9. So again, this only helps us in factoring the denominator. We're kind of on our own for the numerator. So the factors of -18 that have a sum of positive 3 are going to be 6 and -3. So the numerator factors as 9 times x plus 6 times x minus 3. And in our denominator, this is going to factor. Again, I don't need to take the time necessarily to factor this the traditional method. I can use this information right here. So because it's saying x cannot equal 3, I know that it has a binomial factor of x minus 3, because if I evaluate for 3, this equals 0. Now, obviously, 4 times x minus 3 does not give us this original, trinomial, 4x squared minus 24x plus 36. This would only give us 4x minus 12. The reason is this is actually a perfect square trinomial. So what that means is there's actually two of these. There's x minus 3 squared, or I actually prefer to write it out in sort of expanded form like this. X minus 3 times x minus 3. They don't double up. They're not going to put 3 comma 3. That would just be redundant. So they're only going to put the 1, 3 there. So we factored this completely. We've used this sort of to help us out. So now we're ready to simplify. So 9/4. Yes, you could write that as a mixed number, but remember we're trying to simplify these and write these as rational expressions. So we wouldn't want to have a mixed fraction or a mixed number. We want to leave it as an improper fraction. That's fine. X plus 6, there are no x plus 6 factors down here. X minus 3, there is an x minus 3. You are only going to cancel out one of these. You wouldn't do this, right? If we had 4 over 2, if we were to factor 4 as 2 times 2 over 2, you wouldn't simplify this one and this one, right? Because in that case, you would get 1, and we clearly know that 4 halves is not 1. So the x minus 3, we only cross out one of those sort of common factors. So we would still have this other x minus 3. So that's it. That's all we can simplify. So our final answer here is 9 times x plus 6 over 4 times x minus 3. All right, our last problem here. Again, I want to have a positive first term, so I'm going to factor out a -1 right off the bat. If I factor out a -1, I'm left with y squared plus 4y minus 12 over. Now, if we look at this denominator, this is actually a difference of squares. So 4 is a perfect square, y squared is a perfect square. So this actually, I'm just going to factor right away. The square root of 4 is 2. Square root of y squared is y. So I have one binomial that's y plus 2, and the other one is 2 minus y. And we kind of verify this because if I were to evaluate for -2, this factor equals 0. And if I were to evaluate this factor with +2, this would equal 0. In either case, the denominator would equal 0 and the expression would be undefined. So now we have to come back up here and finish factoring our numerator. The factors of -6 that are -12 that have a sum of 4 would be 6 and -2. So the numerator is going to factor as y plus 6 times y minus 2 all over 2 plus y, 2 minus y. Now, when we go to reduce these, remember they have to be identical factors. So the y minus 2 and 2 minus y are very close, just sort of the order is switched. And if we think about a numeric expression to sort of help us think through this, let's say I have 7 minus 3. We all know that that's 4. Well, what's 3 minus 7? Well, that's -4. Well, another way we think through this, and you've probably learned sort of this algorithm or thought through it in the past, if I have a smaller number minus a larger number, it's really just the larger number minus the smaller number, but it's negative. So we could actually think about this, instead of doing 3 minus 7, we just know that that's the same thing as 7 minus 3 negated. So 7 minus 3 is 4, it's just going to be the opposite, -4. All right, so what that means is up here, I know that 2 minus y, okay, 2 minus y, if y was 1, this would equal +1. So that's the same thing as y minus 2, but we would have to negate it, right? So 1 minus 2 would be -1. If we have the negative out front, we get +1. So we're going to get the same value if we evaluate for y in either of these. But by doing this, by factoring out that -1, it sort of switches the order of these two terms around within that binomial factor. So I'm going to have to rewrite my denominator just slightly, so I'm going to do it right below here. So I have 2 plus y. I factored a -1 out from that, and then that reverses or switches the order of these two terms. Now we can reduce. So I'm going to just cross this off. So y minus 2 over y minus 2, that reduces to 1 over 1. The negative 1 over negative 1, that reduces to positive 1 over 1. So we are simply left with y plus 6 over 2 plus y. And if you want to rewrite this denominator in standard form so it's in decreasing order of degrees, you could. We could write that as y plus 6 over y plus 2. And you don't have to worry about factoring out a negative 1 here because with addition we have the commutative property. So we are allowed to just switch the order of those terms around. 2 plus y will be the same thing as y plus 2. So our final answer here is y plus 6 over y plus 2.